This is a 12 volt battery and this is a 48 volt battery. And understanding the considerations of when to choose a 12 volt, a 24 volt, or a 48 volt battery is exactly what we're going to cover today in lesson number 5 of this Battery Basics playlist. My name is Nate and welcome to the EXPLORIST.life Mobile, Marine, and Off-Grid Electrical Academy. Let's get started. There are all kinds of different battery voltages. This is a 48 volt battery. That's a 12 volt battery. That SOK battery over there, that's a 12 volt battery. Victron 12 volt battery. XPN 360 12 volt battery, and Epoch battery. Now this exact same like battery size and footprint comes in a 12 volt, a 24 volt, and a 48 volt version, but understand that whenever I'm talking about battery system voltages, I'm not talking about the actual individual battery voltage, because you could have a 48 volt battery bank made up of 12 volt batteries. You would just wire 4 of those batteries in series, like we've covered in previous lessons in this academy, to change the overall system voltage. Now, what I'm talking about is the overall system voltage, as in what voltage is the entire battery bank operating at. So for example, if we only had one of these batteries, that would be a 12 volt system. If this is a 24 volt battery and we only had one of them, or we had 2 of them wired in parallel, that's going to be a 24 volt battery. Now, I think we've already covered this in pretty good detail in previous lessons, so we're going to go ahead and move forward, given that you understand that. And if you don't understand all of that, go ahead and start this playlist back from video number 1 to get a full understanding of that, because going forward in this video, we're talking about the actual system voltage of the entire battery bank as a whole, and not the individual battery voltages. Whenever I'm designing an electrical system, specifically in regards to battery bank voltages, I'm just going to run through sort of my methods on teaching you guys how we design stuff for our store, shop.explorist.life, and we'll hopefully just make it to the end of this and you'll have some really good insight, because there's a lot of different right ways to design systems. I'm just going to share what I do. So I always start with, how big is your inverter? And more specifically, how big is your overall inverting needs? Because, you know, maybe you've got one inverter, or maybe you've got 2 inverters. If you've got 2 3,000 watt inverters, then your overall inverting capacity is, 6,000 watts. You just add those together. And then that's realistically going to be the main determining factor of 99% of electrical systems. Now, are there DC loads in an electrical system? Yeah, sure, but most of them are pretty small most of the time. And unless you're pushing every single one of your DC loads to its absolute max and pushing your inverters to their absolute max, you don't really have to take that into consideration on, if you're pushing literally everything to its absolute max. So I like to only focus on inverter size whenever I'm making a determination on the battery bank system voltage. And here's the numbers behind what I'm talking about. So if we had an inverter size that was 3,000 watts and it was running at 12 volts, it was a 12 volt 3,000 watt inverter, it's going to be pulling 250 amps whenever it's operating at full capacity. If we had a 5,000 watt 12 volt inverter, that's going to be pulling 416 amps, and that's a lot of power. Now, if we had a 10,000 watt inverter operating at 12 volts, now I don't know that that exists because of how bad of an idea that would be to be trying to pull 833 amps from a battery bank. That's probably why Victron doesn't even make that size. So if you needed to be running a 5,000 watt inverter, that's where we really want to consider bumping to a 24 volt system. So get a 24 volt 5,000 watt inverter with a 24 volt battery bank. That way you're only pulling a little over 200 amps. On the expanding that sort of concept, if you really did need 10,000 watts of inverting power, let's say you had like an off-grid cabin, a house or something like that where you really needed 10,000 watts or more, you really need to go with a 48 volt system because it drops your amperages down to an appropriate level. So you can sort of see that, as our inverting capacities go up in wattages and as our system voltages go a little bit higher, we can use a little smaller wire in the system because our amperages remain pretty consistent. Now, how many amps is too many amps? Well, that's sort of determined by the wire size that is sort of available and is recommended. So, for example, in the Victron Multiplus inverter charger user manual, it actually for the 3000 for the 3 kVA 12 volt version, it recommends 4/0 wire in that for that particular unit, and 4/0 wire is pretty readily available to all of you who are building DIY electrical systems. In our store, shop.explorist.life, we have tons of 4/0 wire because this is a really popular inverter, and that's sort of what we base a lot of systems around, just because it's pretty common, pretty simple, and all that kind of stuff. So 4/0 is really easy to get a hold of. There is wire that's bigger than 4/0, but that's really more for industrial applications. It's really hard to work with. It gets exponentially more expensive. It's just really not realistic to get wire that's bigger than 4/0. Now, if you had a 5,000 or a 5 kVA inverter charger, now Victron does make those, but in the user manual it specs 2 4/0 wires to supply enough power to that inverter, and that's 2 positive 4/0 wires and 2 negative 4/0 wires. So you're talking about a lot of copper. Copper's expensive, and so it's one of those things like it's doable, which is why I've got it in that orangish color, but it's really not recommended. We don't even sell this inverter in our store because of this reason. I just don't think it's that good of an idea. So I don't really like selling things I don't think is a good idea. So we would opt for, if you needed 5 kVA of inverting power, to go ahead and just utilize a 24 volt battery bank system here, so you can use that 4/0 wire. But realistically, if you needed 5 kVA of inverting power, there's sort of not a whole lot of reasons to not go with a 48 volt battery bank system, and then you can use 1/0 wire, which is even smaller. If you have 10 kVA, that can be handled with 4/0 wire, given that you're operating from a 48 volt system, because of those amperage demands that we just talked about on that previous slide. And so this has a lot to do with how we like to design systems. From this side, this way, all of these are going to be appropriate. Now, the problem with choosing different voltages of a system is going to be what parts are available. If you have a motorhome or a van or something like that, and you're like, well, I want to do a 5 kVA inverter charger, and I really want to do a 48 volt system, and I also really want a Victron DC to DC charger. Well, that's it doesn't exist. So Victron, as of shooting this video, things may change, but as of shooting this video, Victron makes an Orion XS in 12 volt and 24 volt, but oops, that should be 48 volt. Can we change that real fast? Cool. 48 volt. So Victron makes the Orion XS in 12 volt and 24 volt, but as of shooting this video, they don't make it in a 48 volt version. So we don't have a Victron based option for charging a 48 volt battery bank from a 12 volt alternator that's comes standard in pretty much every vehicle. So we do have a 12 volt to 48 volt DC to DC charger in our store, shop.explorist.life, but it's from a different manufacturer. It's a Sterling DC to DC charger. Now, it's still a great unit, but it's just not blue. And a lot of people like having, matching brands, and I totally understand that, because, this isn't going to communicate with a Servo GX, but if that's not that important to you, hey, we can get you a 12 to 48 volt DC to DC charger in that regard. But this is another consideration whenever you're choosing a battery bank voltage. Now, another consideration on choosing battery bank voltage is how much solar are you going to put into your system. If you've got a van or a smaller camper where your solar demands don't exceed 1450 watts, we could do a 12 volt system and just use one solar charge controller, because the biggest solar charge controllers sort of like readily available to the consumer market is a 100 amp charge controller. We have those in our store. They're not hard to get a hold of. They're not really specialty items or anything like that. Plenty of stock of those available. But 1450 divided by 12 volts is 100 amps. So we can put all 1450 watts of solar on that single 100 amp charge controller. Now, if you had, nearing 3000 watts of solar, then, it may be worth considering a 24 volt battery bank, because that 2900 watts, that's realistically the most you can put on a 24 volt battery bank. A 24 volt battery bank, it charges at about 29 volts. So 2900 watts divided by 29 volts is 100 amps. And so that's sort of the rule of thumb on that regard. Now, if you had even more solar, up to 5800 watts of solar, a 48 volt battery, it's going to charge at about 58 volts. And so we can take that 5800 watts divided by 58 volts, and that's going to be 100 amps. So, the solar capacity that you sort of plan on installing can really affect the charge controllers that you use and such. Now, if you really wanted a 12 volt system, but you were really going to do 5800 watts of solar, I mean, that's fine. You can put multiple of these solar charge controllers in the same system, and do that. But, every charge controller, it costs money. And if you're trying to sort of maximize your bang for your buck on that deal, you may go with a 48 volt system if you're really doing a lot of solar. That way you can just use one charge controller and stay under that 100 amp output on that side. Now, revisiting the conversation about inverters and parts availability. Now, there's different sizes of inverters like we've already talked about. And so there's a 3 kVA, a 5 kVA, and a 10 kVA inverter charger from Victron. Now, there's other manufacturers and stuff like that, but we're just trying to keep it a little more simple here, even though this is a complicated topic. Now, what we can also have is dual 3 kVA, dual 5 kVA, or dual 10 kVA systems, depending on what your needs are for your electrical demands. You would choose a dual 10 kVA system if you've got an off-grid house or something like that, where you've got, nearing 20,000 watts of, things you need to power, dishwashers, stoves, washers, dryers, all that kind of stuff, hot water heaters, any of those bigger demands and stuff like that would maybe be like a dual 10 kVA system. Now, why would you choose a dual 3 kVA system over a 10 kVA system here? Well, that depends on what kind of input current you have. So, for example, if you have a 30 amp shore power based mobile application, and mobile being an RV, a van, a travel trailer, or even a boat, something that is not hardwired to the national electric grid at all times, that's going to make a big determining factor on what inverter chargers you can use. Now, from Victron, if you're doing it like this, a 3 kVA, a 5 kVA, and a 10 kVA, those are single phase 3-wire input with a hot, a neutral, and a ground. And that's a pretty standard, pretty typical input, pretty typical inverter charger. There's really not a whole lot of considerations there. And so, based on the rules that we laid out earlier about wire sizing, with a 3 kVA system, if you have a 30 amp mobile application, a 12 volt, a 24 volt, or a 48 volt, that's going to be perfectly fine for all of those. Now, if you have a 30 amp mobile application, you need a 5 kVA of inverting power, then a 48 volt version is going to be great. A 24 volt version also going to be good. 12 volt version is doable with that dual 4-aught wire that we talked about earlier, but I got a exclamation mark next to that because it's not really that good of an idea. It's available, but I wouldn't recommend it. Now, if you had a 10 kVA system, you had quite a bit of power that you're needing to do. Same concept as here, but this doesn't exist, this doesn't exist as an actual component, but the 48 volt version does exist. So if you needed this much inverting power to power 10,000 watts or nearly 10,000 watts of devices, you sort of only have the option of doing 48 volt systems. Now, for dual 3 kVA, dual 5 kVA, or dual 10 kVA, if you have single phase 3-wire input, we can do any of those, but it sort of doesn't make sense. It's just more parts, more components, more complexity and getting the wires to where they actually need to go, where it sort of doesn't make sense. In a dual 10 kVA system, like 20,000 watts of power on a 30 amp mobile application, a 30 amp mobile application, hey Steph, quick math, 30 times 120. 3,600. So that's 3,600 watts of power coming in from shore power. So realistically, having dual 10 kVA inverter chargers on a 30 amp, that's way more power than the breaker box can handle. And you're going to start tripping breakers if you ask that to pull that much power. That's just, it doesn't make sense. So I have the exclamation marks there just to show that, hey, this doesn't really make sense. I mean, it is possible, but why? So a 50 amp mobile application, 50 amp shore power is split phase, 2-wire. So there's a hot 1, hot 2, neutral, and ground. And each one of the hot leg 1, hot leg 2, they're both carrying 50 amps in a 240 volt or 120, 240 split phase application. And so that we are limited by actual inverter availability, because you'll notice that 5 kVA here, we don't have any options. We've got X's across the board here as well as here. That's because with Victron, at least, they don't make an inverter charger that has enough wire slots for 120, 240 input for either of these sizes of inverters. So, as of shooting this video, that's just simply not an option. Our option here for a 50 amp mobile application is to use the 3 kVA version, because they have a line of inverter chargers, their 2X120 line, that handles L1 input, L2 input, plus the neutral and the ground. And that particular inverter, the 2 kVA or the 2X120, 3 kVA, 450 amp mobile applications, it's available in both a 12 and a 24 volt version. So you can kind of select either one. At this point in time, I sort of don't see a reason to go 12 volt, based on just how we design systems. So I'd say 48 volts your best choice there. Now, if you needed more power than that, totally understand, because that's a lot of power, and this can't power more than one air conditioner. If you had more than one air conditioner or more than one, high powered load in your RV, you're going to want to start looking at the dual systems down here. And we can do a dual 3 kVA system with single 4-aught wire, like we talked about earlier, with both a 24 and a 48 volt system. 12 volt, it sort of gets too many amps, very similar to how we've got this exclamation mark, but 6 kVA versus 5 kVA sort of puts it over the threshold. So I've got a red X right there. Now, once you step up to dual 5 kVA systems and you're, nearing 10,000 watts of inverting capacity, realistically that has to be a 48 volt system, and then dual 10 kVA system would be 48 volt system, just basically due to what's available. Now, in those dual systems, those work just fine where these don't, because these don't have to be the 2X120 line of inverter chargers, because we're asking one of the inverters to handle line 1 of shore power and the other inverter to handle line 2 of shore power. So you're sort of just breaking up that shore power input. Now, if you have an off-grid stationary application, like an off-grid house, a cabin, or anything like that, because we do have systems like this available at shop.explorist.life, and I have exclamation marks by everything that's not 48 volt systems, because with an off-grid stationary application, you're never trying to charge from a 12 volt alternator, because stationary applications don't have motors. And you're generally not trying to power 12 volt loads. You're not running, cigarette lighter adapters around your off-grid cabin in most cases. I mean, maybe you are, but I don't think that's a good idea, but that's just my opinion. So I have exclamation marks by everything that's 12 and 24 volt. I think 48 volt systems make sense across the board if you have a stationary application, regardless of sort of what you have going on. These dual systems over here are going to be great for off-grid houses, off-grid cabins in a 48 volt configuration, because you're going to be able to use just a standard residential breaker box that you can pick up at Home Depot or Lowe's. So as far as shop.explorist.life goes, we're going to be able to supply the DC side of system all the way up to the inverter, and then everything after the inverter is going to be standard household wiring that you could just find locally at a Home Depot and such. These systems over here, These are great for like totally off-grid applications, maybe like a shed, something where you've got like some, DeWalt batteries. You're trying to power a couple lights just in the shed that you've got and stuff like that. We've sold a couple of these systems in a 48 volt version, but that sort of gets away from the 12 versus 24 versus 48 volt version. Everything we've talked about thus far, really lands us at 48 volts for all of these systems. So this has been a pretty complicated video. We've made a lot of these recommendations based on us being involved in over 30,000 electrical system installations, through our store over the years. And so if you need help, we do have help available, and you can just reach out to us at shop.explorist.life/support, and we can get you pointed in the right direction. Now this is a video that we've remade from previous years, and my opinions on this stuff has changed based on parts availability, because there's way more parts available now than there was 2 or 3 years ago when we made this video last time around. And we're probably going to make this video again here in another 3 years whenever Victron has a bigger 2X120 inverter charger available. So all this stuff is always changing. So if you're watching this in 2025 versus 2028 or whatever the case is, just reach out, shop.explorist.life, and we can get you pointed in the right direction. The next video we are going to be covering understanding something or another. What are we covering? I just wrote understanding, and that was all I wrote. Now in the next video, we are going to cruise on forward and go to something that's maybe a little less complicated, fortunately, and we're going to cover understanding power densities of the various batteries, because this is a 200 amp hour 12 volt battery, and that's a 100 amp hour 12 volt battery. And we're going to talk about why they're so similarly sized, but the same capacities. So we'll see you over there. So there's really no wrong way or right way to design the assist. There's wrong ways to this. There's a lot of wrong ways actually.